In the grand theater of technological progress, our focus is often captured by the spectacle of speed, power, and dazzling new features. Yet, beneath the surface of every innovation lies a more profound question. Who is it for? For too long, the digital world, like the physical one before it, was built upon a set of implicit assumptions about its inhabitants, a silent consensus on what constitutes a normal user. At its hypothetical WWDC 2025, Apple has chosen to confront this legacy head-on, presenting not just a series of new tools, but a foundational shift in design philosophy. This is a call to architects of the digital age to move beyond designing for the average and to begin consciously engineering for the rich, complex, and beautiful variants of the human condition. This episode of Byte Chronicles delves into the core concepts of Apple's renewed accessibility and inclusion drive. We will explore the intellectual framework that underpins this movement, dissect the practical pillars of inclusive design, and examine the powerful new tools, from transparent nutrition labels to the revolutionary Assistive Access, that empower developers to build a more equitable digital future. This is not merely a technical update. It is a masterclass in the architecture of belonging. Let's start with the foundational premise, understanding the inclusion gap. At the heart of Apple's entire approach is a powerful reframing of disability itself. The philosophy posits that disability is not an inherent trait of an individual, but rather a mismatch between a person's abilities and the environment they must navigate. Society, often unconsciously, designs physical and digital spaces based on a narrow range of assumed human capabilities. When a person's way of seeing, hearing, moving, speaking, or thinking deviates from this implicit norm, they encounter barriers. This chasm between individual ability and environmental expectation is termed the inclusion gap. The existence of this gap is what creates exclusion, but crucially, the effort to close it is what drives innovation that benefits everyone. Consider the real world. Curb cuts, designed for wheelchair users, are now indispensable for parents with strollers, travelers with rolling luggage, and delivery workers with carts. Microphones, essential for amplifying sound for those with hearing loss, are now the foundation of voice assistants, podcasting, and global communication. Eyeglasses, a correction for vision impairment, have become a tool for fashion and a means for anyone to reduce eye strain in a screen-dominated world. In each case, a solution created to close an inclusion gap for a specific group made society more flexible, convenient, and capable for all. Apple's thesis is that the same principle applies with even greater force in the malleable world of software. By making a conscious effort to close the digital inclusion gap, we don't just create apps for disabled people. We create better, more resilient, and more human-centered apps for everyone. This requires abandoning assumptions and embracing a new set of design principles. Now we move to the core pillars of inclusive app design. To translate this philosophy into practice, Apple has outlined 4 core pillars, actionable strategies that form the blueprint for building truly inclusive applications. Firstly, the support of multiple senses and the power of redundancy. The most fundamental way to close the inclusion gap is to avoid relying on a single sense for interaction or information conveyance. An inclusive app provides multiple, redundant pathways for users to perceive content and provide input. Every person experiences the world differently. Someone may be in a loud environment and unable to hear audio. Someone may have a temporary motor impairment from an injury. Someone who is blind relies entirely on audio and haptic feedback. By providing information through visual, auditory, and haptic channels, you cater not just to permanent disabilities, but to the vast spectrum of situational and temporary impairments. Captions for video are a classic example. They are essential for users who are deaf or hard of hearing, but they are also used by millions of people watching content in a quiet office, on public transit, or with the sound off at night. The new Accessibility Reader feature exemplifies this principle beautifully. It allows a user to consume text not just by reading it visually, but by listening to it as audio or by following along with simultaneous audio and text highlighting. This multimodal approach allows people to experience content in the way that best suits their needs and learning style. The directive is clear. Explore how every key piece of information and every critical interaction in your app can be represented through more than one sense. Next, we move to providing customization. From one-size-fits-all to one-size-fits-one. Supporting multiple senses is the first step. The next is recognizing that even within a single sense, needs vary dramatically. Customization empowers users to tailor the interface to their specific requirements, transforming the app from a rigid object into a malleable tool. The idea of a perfect interface is a myth. One person's data-rich, complex dashboard is another person's overwhelming wall of cognitive noise. One person's ideal font size is illegible to another. Customization hands control over to the user, allowing them to sculpt the experience to fit their own visual, cognitive, and motor preferences. Accessibility Reader again serves as a prime example, allowing users to fine-tune the visual experience by adjusting text size, spacing, fonts, and color themes. Adoption of accessibility APIs leads to building bridges to assistive technology. Once an app is designed with flexibility, it must be able to communicate with the specialized tools users rely on. This is where accessibility APIs, application programming interfaces, become critical. Think of an accessibility API as a universal translator. It's a bridge that allows your app to describe its elements and functions in a standardized way to assistive technologies like VoiceOver, a screen reader for blind users, switch control for users with significant motor impairments, and voice control for hands-free navigation. Without adopting these APIs, your app is a black box to these technologies, rendering it unusable. The puzzle game Black Box is presented as a stellar example of API adoption in an unexpected domain. A game that relies on visual cues and environmental interaction would seem inherently inaccessible to a blind player. However, the developers meticulously used the APIs to make it a rich auditory experience. Through VoiceOver, every element is described. Haptic feedback provides physical cues, and carefully designed audio labels guide players through challenges, proving that with thoughtful implementation, even the most visual experiences can be made universally accessible. Tracking inclusion debt is necessary for the commitment to continuous improvement. Inclusivity is not a final destination. It is an ongoing process. Inclusion debt is a powerful concept that frames accessibility not as a feature to be checked off a list, but as a core aspect of product quality that must be managed over time. Conceptual basis, just like technical debt, where quick and dirty code creates problems later. Inclusion debt accumulates when design and development shortcuts are taken that create barriers for users. Perhaps a new feature is rushed out without proper voiceover labels, or a new color scheme fails contrast checks. In practice, the key is to acknowledge this debt, track it, and actively work to pay it down. This involves creating a culture where accessibility is part of the design and QA process from the beginning. It means collaborating directly with people with disabilities to understand where the gaps are and making conscious, informed decisions to close them. This iterative process leads to more flexible, robust, and truly inclusive products over the long term. Next, we shift our focus towards the accessibility nutrition labels. The key to making accessibility transparent, to empower users and create accountability for developers. Apple is expanding its nutrition label concept to accessibility. These labels, displayed prominently on an app's App Store product page, provide clear, at-a-glance information about the specific accessibility features an app supports. There's the developer's responsibility. Creating an accurate label in a multi-step process by identifying common tasks in which developers must first map out the core user journeys in their app, like login, making a purchase, changing a setting, creating content, evaluate against features. Each of these tasks must then be evaluated against the full suite of available accessibility features. Can a user log in using only voice control? Is the purchase button clearly labeled for VoiceOver? Does the text in the settings menu scale properly? Test on every device. Testing must be performed on every device the app supports, as layouts and interactions can differ between iPhone, iPad, and Mac. Publish an App Store Connect. Once evaluated, developers select the supported features in App Store Connect to generate the label. Here are the key accessibility label features. Sufficient contrast. Text and important UI elements must have a high contrast ratio against their background to be legible for users with low vision. This should be tested with the system's Increase Contrast setting enabled. Dark interface. Supporting dark mode is crucial for users with light sensitivity or photophobia. It's more than just inverting colors. It requires testing to ensure all elements remain distinct and compatible with other features like Smart Invert. Larger text. Apps must support dynamic type, allowing text to scale up to at least 200% without being truncated, overlapping, or becoming trapped in non-scrolling fields. Differentiate without color alone. Color should never be the only way to convey important information. Because of color blindness and other vision differences, status and alerts must also be communicated with shapes, icons, patterns, or text labels. Reduced motion. When the reduced motion setting is on, apps must minimize or eliminate jarring animations, parallax effects, and flashing or sliding transitions that can trigger vertigo, nausea, or seizures in susceptible individuals. Let's take some deep dives into accessibility in SwiftUI and Assistive Access. Apple is also providing powerful, platform-specific tools to make implementation easier and more profound. For macOS apps, SwiftUI now offers enhanced control over the accessibility tree, the invisible map that VoiceOver uses to navigate an app. The key is to create a logical, efficient structure. That's accessibility on macOS with SwiftUI. Grouping. Related controls, like a text style and its Apply button, can be grouped into a single, understandable element. This prevents a user from having to tab through multiple, disconnected pieces to perform one action. Prioritizing. The Accessibility Sort Priority modifier allows developers to reorder how elements are read, ensuring that the most important information, like a title or summary, is presented first, regardless of its visual position on the screen. Beyond the pointer, all interactions must be achievable without a mouse. This means implementing robust keyboard shortcuts and custom accessibility actions that work seamlessly with VoiceOver, switch control, and voice control. What is Assistive Access? It's a revolution in cognitive accessibility. Perhaps the most significant new feature is Assistive Access, a specialized iOS and iPadOS mode designed for users with cognitive disabilities. It provides a radically simplified and streamlined system experience. The core idea of Assistive Access distills the interface down to its essential components, featuring large, clear controls, prominent visual alternatives to text, and consistent, predictable navigation. It reduces cognitive load by eliminating distractions, hidden gestures, and complex pathways. For developer integration, they just need to opt in. Developers can optimize their app for this mode by adding a key to their apps bundle, allowing it to run in a dedicated full-screen experience. Create a scene using SwiftUI, and then developers create a separate Assistive Access scene. This scene presents a lightweight, distilled version of the app's core functionality. The system automatically styles native controls in the larger, clearer grid or row-based layout that is standard for Assistive Access. There are a few design principles for Assistive Access like distill to the core. Focus on one or two essential features of your app. Prominent, clear controls. Use large buttons with both icons and text labels. No hidden gestures. All actions should be initiated by a clear, tappable control. Avoid relying on swipes or long presses that are not explicitly indicated. Safe navigation. Step-by-step navigation is key. The system provides a consistent back button. Irreversible actions should be removed or require multiple, clear confirmation steps. By optimizing for Assistive Access, developers can create a safe, supportive, and empowering environment, unlocking the power of their apps for an audience that has long been underserved. The mandate is for a more human-centered future. The initiatives unveiled at Apple's WWDC 2025 represent more than a checklist for compliance. They are a profound statement of values. The message is that true innovation is not measured solely by what a technology can do, but by who it can empower. By embracing the concepts of the inclusion gap, supporting multiple senses, offering deep customization, and leveraging powerful new tools like accessibility nutrition labels and Assistive Access, developers are given both the why and the how. We got to see accessibility not as a final polish or a niche requirement, but as the very foundation of good design. It is a commitment to building digital curb cuts, elegant solutions born from empathy that ultimately create a more flexible, more capable, and more profoundly human digital world for everyone. The architecture of belonging is not built by accident. It is built by design, and the blueprints are now in our hands. So this is the end of this episode of Byte Chronicles, where we explored accessibility in detail. Hope you liked it. Thanks for watching. We'll see you in the next one. Until then, keep exploring and keep biting.